All right, here's an example of a second order equation. So we're looking at this particular second order linear equation with a constant coefficient for simplicity, and usually we look at this type of initial conditions. Then we can write it as this operational form, and if there is a constant coefficient, we can easily factor. So first order and followed by another first order operator. So copy down the operator here, and again what we're looking for is we're going to do some operator on the left so that it kind of annihilates one at a time. It gets rid of this d and that d, leaving I and some other factor that it's manageable, not difficult to so that we can solve the equation. So the main point is getting rid of the one at a time. So this one, to get rid of this one, we have to play with e to the 2x. So that's, let's use that corollary. So here's the part. If you do e to the 2x, and because we're looking at this initial value problem at 0, so we're integrating with respect to 0 at 0, and here e to the negative 2x. If you go through this operator, what happened to this part is I minus some evaluation operator, right? So this is what we have. What happened to this part of the operator is I minus e to the negative 2x, some evaluation operator in here. So e0 and e to the 0 is 1, so it's this part simple. So if you distribute this one from the right, we have a d minus I, and this is d minus I e to the negative 2x e0. If you look at this part, if you apply the function in here, that means y prime minus y, and evaluating the 0. So this is going to be a constant function multiplied by e to the negative 2x. This is completely determined by this initial condition. But it is expressed it here as an operator form. So that whole thing becomes this one. So this is not the typical first order operator we've been looking at. Usually it's just d minus something times I, and that's it. There is no this evaluation term. But we know what happened if you multiply by another of this type to the here, that at least is gonna distribute to this part and do something nice about that part. And then we'll see what this part does, this type of thing does to this factor in here. So we're going to hit this entire thing to annihilate this d minus I operator. So we're going to hit this entire operator, the product of two typical linear first order operator, by this one, because we're looking at this negative 1, so that should have been negative x, and this should have been positive x. I'm going to fix it. Alright, it's fixed now. That's going to be applied to the whole thing. So here's one way to look at it. First, we multiplied this one, so it kind of simplified this d plus 2i, and there was still the d minus I was left over after we simplified this part right here, and we're doing this one to kind of get rid of d minus I that showed up in here. So I'm copying down this part down here, which was this much of the operator, whole thing done. As an operator algebra, it simplifies to that. And we're multiplying these three operators there so that we can do something about this d minus I. So that's going to be distributed to that because these are linear operator. So that by that corollary, if this is applied to d minus I, it's I minus. This whole thing is e to the positive x, that part becomes there, and e to the 0, and evaluation, and e is f0, that's this part, and that whole thing is operated on that part. So it's e to the x, and integral e to the negative x, and followed by this one here. Now we have this I that'll pick up just the solid y in there, and this one will be, because of this evaluation operator, it's going to be some nice constant multiplied to this function e to the x. And if you look at this part, and this involves the initial values. Because of this evaluation operator, initial value add derivative, derivative initial value, and function value, constant multiply to that, and integrate. So these are something that's completely under control with this initial value in here. So this will do exactly the job of computing. Actually, pretty much the work as an inverse operator, these two things.